Okay, so this is the last part of Section 3.3 video lecture. If you've not watched the first part of Section 3.3, be sure you go back and do that first. This last part of Section 3.3 covers the conjugate zeros theorem. And so let's start here with our properties of conjugates and make sure we all understand what a conjugate is. And it says for any complex numbers C and D, the following properties hold. A plus BI, and notice this bar over it, so that's really read the conjugate of A plus BI. So when there's a bar over it, that means the conjugate of A plus BI would equal A minus BI. So in other words, the conjugate of A plus BI is equal to A minus BI, and vice versa. The conjugate, because it's got this bar over it, the conjugate of A minus BI equals A plus BI. And so again, this is just explaining here that the conjugate of A plus BI is A minus BI, and the conjugate of A minus BI would be A plus BI. So you just are changing the sign in the middle to get the conjugate, okay? So if f of x defines a polynomial function having only real coefficients, and if z equals A plus BI is a zero of f of x, where A and B are real numbers, then the conjugate of z, which in this case, since z was A plus BI, the conjugate of that would be A minus BI, is also a zero of f of x. So let's just kind of think about that in more plain terms. So if they gave me that 3 minus I was a 0, then I know for sure the conjugate of that, 3 plus I, would also be a 0 of that polynomial. We could have given negative 5I is a 0 of a given polynomial, then I know for sure by this conjugate zeros theorem that the conjugate of negative 5I would also be a 0, which would in this case be positive 5I. Okay, so let's use that conjugate zeros theorem to find zeros of a polynomial function on the next page. And so this is example 6. And it says find all zeros given 1, 0. And it says find all zeros of f of x equals x to the 4th minus 7x cubed plus 18x squared minus 22x plus 12, given that 1 minus I is a 0. Notice that they're giving me a complex number as a 0. And so I still am going to start with what I'm given. And this is what's going to go outside the house first, 1 minus I. And again, I'm going to use some blank paper so we have some more room. And so if I look at this, I'm going to put 1 minus I outside the house. And I'm going to put my coefficients of my function inside the house, and I'm going to check for those missing terms always first. So I have x to the 4th, x cubed, x squared, x to the 1st constant. No skips, so to speak. So I'm going to put my coefficients in order the way that they are. No zeros needed. So I put positive 1 first, then negative 7. And you want to really space these out since you're dealing with a complex number here. Then positive 18. Then negative 22, and then finally positive 12. And we're going to bring down this first number. And so I'm going to multiply 1 minus I times 1 is 1 minus I. It is very important that you keep the real number parts lined up under each other, okay? Put the I part second here. And so I can combine the real number parts here. Negative 7 plus 1 gives me negative 6, and bring down minus I. Okay, so now I need to multiply 1 minus I times negative 6 minus I. Okay, and so again, I showed you in an earlier lesson how, and you should have learned it also in a previous chapter, how to use your calculator to multiply that, or you can fool this. But 1 minus I times negative 6 minus I would give me negative 7 plus 5I. And notice again, I'm lining up the real number part under each other. Now subtract 18 minus 7 gives me 11 plus the 5I. And then I'm going to multiply 1 minus I times 11 plus 5I. And again, you can use your calculator to multiply that. Will give us 16 minus 6I. line the real number part up. Negative 22 plus 16 gives me negative 6 minus 6i. And so now I'm going to multiply 1 minus I times negative 6 minus 6i. And that would give me negative 12. And so 12 minus 12 gives me that remainder of 0 that I definitely should get here. Okay, so now that conjugate 0 theorem said that if 1 minus I is a 0 of this, then also the conjugate of this has to be a 0. The conjugate of 1 minus I would be 1 plus I. And so that is what is going to go outside of my house next. Okay, well, what goes inside of the house here? Well, the result I got when I first did my first synthetic division, that's what will go inside the house on the next step. So I went from 1 minus I that was given. The conjugate of that is 1 plus I. That's my next step. That's what should go outside the house next. And then whatever result I got here when I did my first synthetic division, that's what's going to go in here as my coefficients inside the house here. So I'm going to put positive 1, then that negative 6 minus I, then 11 plus 5i, then negative 6 minus 6i. And I'm always going to bring down this first number. Okay, we'll multiply 1 plus I times 1 would just be 1 plus I. Well, I can combine negative 6 plus 1 and get negative 5. And the negative I plus I would be 0. So I'm just left with negative 5 here. I can multiply now 1 plus I times negative 5. You can do distributive property, or you can type that in your calculator with parentheses, and I will show you that one just in case, because I know I haven't showed you that earlier. So parentheses, if I want to multiply 1 plus I times negative 5, I would do parentheses 1 plus second decimal point for your I, close it, times, and use your negative key, negative 5. And that gives me negative 5 minus 5i that goes here. Or again, you can just use your distributive property and do it. 11 minus 5 gives me 6. 5i minus 5i is 0. 1 plus I times positive 6, if I use calculator or do your distributive property, I would get 6 plus 6i, which works out because I get a remainder of 0. Okay, well, we know that this is a 0. This was given. We know the conjugate is also a 0. That was our next step. And so if you look back and think back to our original synthetic division problem we first worked, if this started out, our given function started out leading term was x to the 4th, then that means on this process, the first time I did my synthetic division, this would have been the coefficient of x to the 3rd. And now finally, this result here, this first number is the coefficient, then we're down to x squared minus 5x plus 6. Why is that so important? Because now it's quadratic, and so I can use my quad 4 program, or I can use, this is factorable, you can factor it, or you can do quadratic formula out with pencil and paper. But I will take this, x squared minus 5x plus 6, and so you can use quad 4. And so A would be positive 1, B would be negative 5, and C would be 6. And it will tell you that x equals positive 2 or x equals 3. And so my zeros, my other zeros, you're not going to list the one you were given. Okay, we were given 1 minus I. The other zeros that I would give to give my final answer would be 1 plus I, comma, 2, comma, 3. And those would be the other zeros for that function. Okay, because the only given example here was the one with a complex number given as a 0, I want to work with you myself number 29 from your textbook exercises, and I'm going to write that down on a sheet of paper, but you are welcome to find it in your textbook. Number 29 has the same directions. Find all zeros of f of x equals, and this is number 29 in your textbook, of f of x equals x cubed minus x squared minus 4x minus 6, given that 3 is a 0. Okay, so it's very similar to this first one that we've worked here already together, okay? So the reason I wanted to show you number 29 myself is that they're not giving me a complex number here. They're just giving me 3. So you cannot apply that conjugate zero theorem to this because this is not a complex number. A lot of times students think because they're given 3 as a 0, that means automatically negative 3 is a 0. That is not the case. The only time you can apply that conjugate zero theorem is when you're given a complex number. In other words, a number here like this with the I. So you cannot apply that here. So how would I work this one? Well, I'm given that 3 is a 0, so I start with 3 outside the house. And then I look to make sure these are going to be put inside the house, the coefficients here of my terms, and I make sure I'm not missing any. So 3, 2, 1, my constant. So there's no skips, so I'm going to put my coefficient of 1, then negative 1, then negative 4, then negative 6. And I'm going to bring down this first number. 3 times 1 is 3. Negative 1 plus 3 is positive 2. Multiply 3 times 2 is 6. Negative 4 plus 6 would give me positive 2. 3 times 2 is positive 6. And I get a remainder of 0. Okay? And so again, if I started out with x to the third, that means this is the coefficient of x squared. So I have 1x squared plus 2x plus 2. And because it's x squared, that makes that quadratic. So again, I'm going to take this, and I'm going to use my quadratic formula. And you can use quad 4. So A would be 1, B would be 2, C would be 2, and so let's go to quad 4. A is 1, B is 2, C is 2. Notice I'm going to have a negative under my radical here, and so we hit enter again, so we have negative 1 plus or minus 1i is how I would write that answer. So x equals, again, negative 1 plus or minus 1i. Okay? And so that means this would be my other two zeros. Negative 1 plus 1i, negative 1 minus 1i. And you don't have to put that understood 1. So for MyLabs Plus, when you're actually doing your homework assignment for this, you would type it in as negative 1 plus I, comma, negative 1 minus I. And that's how you would give those other two zeros, okay? So I just wanted to be sure and show you one that did not give you a complex number, but yet said to find all other zeros. So these would be my other two zeros I was looking for number 29. Okay, so now you need to make sure, we've already worked 29 here, so work 7, 13, 31, and 35 on page 315, and you can check those in the back of your textbook.